In the last few hours, unusual reports have begun circulating from Yellowstone National Park. Visitors and online users have been sharing photos and videos across TikTok and Twitter showing animals engaged in strange circling behaviors. What began as isolated posts quickly grew into a wider conversation as people started linking the sightings together, building a larger picture of something that appears to be happening across the park. One of the most widely shared accounts came from a woman named Grace. After finally realizing her dream of visiting Yellowstone, she described seeing a group of bears that caught her attention. At first, she assumed she was witnessing normal behavior, but her curiosity deepened as she realized the bears were moving in deliberate circles, tracing paths worn into the ground. Expecting them to stop after a few turns, she was surprised when the circling continued. A moment later, she noticed another bear in the distance following the same pattern. What she observed struck her as unusual enough to share online, and her words soon spread, being echoed by others who had seen similar scenes. Grace's testimony was supported by further reports from other visitors. Birds were said to be flying in looping patterns, returning to the same airspace again and again before dispersing suddenly. Such observations may sound puzzling, yet they align with what has long been recorded about animal behavior when natural forces shift beneath the earth. Many animals are believed to have heightened senses that allow them to detect vibrations, electrical changes, and chemical emissions in ways humans cannot. Their movements, no matter how strange they appear to observers, may serve as natural responses to environmental changes. For centuries, cultures have documented how animals appear to anticipate disasters. Historical accounts describe livestock, pets, and wildlife behaving restlessly before devastating earthquakes. In modern times, research has supported these accounts, with studies confirming that animals can sense subtle vibrations or fluctuations in the magnetic field. Even silkworms have displayed measurable changes in their behavior when exposed to seismic activity. Dogs, cats, and farm animals have been observed acting in strange ways before the ground begins to shake, while birds and fish often flee from areas about to be affected. The behavior observed in Yellowstone seems to fit into this larger pattern. Circling movements are often interpreted as signs of disorientation or as reactions to magnetic shifts. Birds and mammals alike are known to navigate partly by sensing the Earth's magnetic field, and any changes in that field can disturb their patterns. In a place like Yellowstone, where geothermal and volcanic activity are ever present beneath the surface, the possibility of such disturbances is never far from consideration. The notion that animals act as natural sensors for disasters has gained recognition due to events such as the Indian Ocean tsunami in 2004. Before the towering waves struck coastal regions, elephants were seen moving inland, while flamingos abandoned their nesting grounds. The seismic vibrations from the undersea earthquake that caused the tsunami may have been detected by the animals, giving them time to react while humans remained unaware. These examples highlight how wildlife can serve as indicators of forces beyond human detection, and they illustrate why reports from Yellowstone have drawn such intense interest. When earthquakes occur near the shore, they can produce tsunamis that rise higher than 100 feet, reshaping coastlines in moments. On land, tremors alone can devastate vast regions. These immense powers of nature make the behavior of animals all the more significant, as they may provide early warning signs that could one day help protect human lives. The circling of bears and the looping flight of birds in Yellowstone may be another example of such behavior, potentially signaling shifts beneath the earth that are not yet visible. The spread of these accounts has been amplified by social media. What may have remained isolated observations in years past has now become a shared experience, pieced together in real time by individuals across the world. A photograph of circling bears or a video of looping birds becomes more powerful when others confirm having seen the same thing. Within hours, these scattered posts form a narrative that points to something larger, something that deserves attention and reflection. The mystery remains unresolved, but what is clear is that the animals of Yellowstone are acting in ways that cannot be ignored. Their circling movements and unusual patterns serve as reminders that wildlife remains deeply connected to the rhythms of the earth. Long before humans developed instruments to measure tremors, animals felt the pulse of seismic and magnetic shifts. When they act in unison, as seen in Yellowstone, The signs should be taken seriously. The events of the past few hours have left observers both intrigued and uneasy. Grace and others who witnessed the circling animals experienced something they will never forget, and the videos and photos now circulating have ensured that the world will be watching closely. The behavior of Yellowstone's wildlife has brought renewed attention to the idea that the natural world holds knowledge humans have not yet mastered. As the bears and birds continue their strange movements, their actions stand as silent messengers of forces stirring beneath the earth, a reminder that the natural world often knows what is coming long before humanity does. Recently, the park has experienced a swarm of earthquakes, drawing attention from scientists, tourists, and the general public. These seismic events have raised concerns about the stability of the Yellowstone caldera, often referred to as the Yellowstone supervolcano, and they come just days after tourists at Yellowstone National Park managed to film the terrifying moment when a massive explosion occurred, causing them to flee in fear for their safety. The footage reveals numerous guests quickly evacuating a boardwalk located dangerously close to a scorching hot spring. Biscuit Basin has been completely closed off by the National Park Service as geologists conduct an investigation into the incident. This occurrence once again prompted speculation on the potential impact of these earthquakes on the national park. Some individuals who examined the data provided by the United States Geological Survey have noted the absence of certain portions. For instance, they reported that on certain days, only a few hours of the day were displayed, while the remainder was left unaccounted for. Consequently, certain individuals questioned whether certain information was being withheld. While the United States Geological Survey has acknowledged the occurrence of these minor tremors throughout Yellowstone National Park, some individuals are expressing greater concern about the occurrence of more significant earthquakes in the region. They question why these events have not been addressed by park authorities and media organizations. Graphs depicting Yellowstone indicate that the occurrence of these earthquakes had observable consequences on the park, since there was evidence of magma movement. There is another earthquake that has not been reported, which had a magnitude of 2.4. The graphs indicated a seismic event of greater magnitude than usual that occurred in the region, but no information or communication was provided regarding this occurrence. Upon the dissemination of the photographs, individuals began to inquire as to why this information was being withheld. There are hypotheses suggesting that the reason for not disclosing information could be to prevent causing anxiety among the public. Alternatively, others speculate that there might be ongoing events in the Yellowstone area that authorities are aware of, but choose not to disclose. Dr. Poland stated that the earthquakes that have been observed are within the expected range of normal activity. The Yellowstone system exhibits high levels of tectonic activity, resulting in an average of around 1,500 to 2,500 earthquakes each year in the surrounding area. Typically, Yellowstone experiences between 100 and 200 earthquakes every month, primarily resulting from minor faults. The convergence of a fragile crust, elevated temperatures, numerous faults, and active subsurface water movement generates optimal circumstances for the occurrence of several smaller earthquakes. Scientists have recently stated that the animals residing in Yellowstone National Park have been engaging in migration. According to certain studies, animals have the ability to detect variations in electrical fields or the discharge of gases from the earth. This is why some animals seek refuge when an earthquake is imminent. In the last 2 years, this supervolcano has demonstrated to scientists its ongoing activity. Researchers said that last year, 2 out of the 3 indicators signaling an imminent eruption were detected. These indicators consist of a rise in seismic activity and an escalation in the number of gas vents on the surface. In addition to this, researchers at the park have reported the emergence of new erupting vents and surface fissures. They have been compelled to shut down a boardwalk in the well-liked upper basin. Currently, researchers are monitoring the activity closely. Due to its potential for catastrophic eruptions, the supervolcano is under constant surveillance by scientists and governmental agencies. While the likelihood of another super eruption occurring in the near future is low, the potential consequences of such an event are immense. A super eruption could spew thousands of cubic kilometers of ash and pyroclastic material into the atmosphere, significantly impacting global climate, agriculture, and human health. Even smaller eruptions or hydrothermal explosions within the caldera could pose significant risks to the park and surrounding areas. The primary reason for monitoring the Yellowstone supervolcano is to protect public safety. Surveillance of the supervolcano also advances scientific understanding of volcanic processes and hazards. Yellowstone is a unique natural laboratory for studying geothermal and volcanic activity. By monitoring the volcano, scientists gain insights into the mechanics of caldera systems, magma movement, and the triggers of volcanic eruptions. This knowledge not only enhances our understanding of Yellowstone, but also improves our ability to predict and prepare for volcanic events worldwide. One of the primary tools for monitoring the Yellowstone supervolcano is seismic monitoring. The Yellowstone Seismic Network, operated by the United States Geological Survey and the University of Utah, consists of over 50 seismometers distributed throughout the park. These instruments detect and record earthquake activity, providing data on the movement of magma and geothermal fluids beneath the surface. Increased seismic activity can indicate changes in the volcanic system and potential precursors to eruptions. Scientists also monitor ground deformation to detect changes in the shape of the Earth's surface caused by magma movement. The Yellowstone Volcano Observatory employs a combination of GPS stations, satellite-based interferometric synthetic aperture radar, and borehole strain meters to measure ground deformation with high precision. Uplift or subsidence of the ground can signal changes in magma pressure and movement, helping to assess the likelihood of volcanic activity. Geochemical monitoring involves analyzing the composition of gases and thermal waters at Yellowstone's geothermal features. The release of gases such as carbon dioxide, sulfur dioxide, and hydrogen sulfide can provide clues about magma movement and volcanic activity. By sampling and analyzing these gases, scientists can identify changes in the volcanic system and assess the potential for eruptions. Remote sensing technology, including satellite imagery and aerial surveys, plays a crucial role in monitoring Yellowstone's supervolcano. Satellites equipped with thermal imaging and spectrometers can detect changes in surface temperatures and gas emissions. The continuous monitoring of Yellowstone's supervolcano is integral to developing and maintaining early warning systems. By detecting signs of increased volcanic activity, scientists can provide timely alerts to governmental agencies and the public, allowing for preparedness measures and potentially saving lives. Effective communication and coordination among federal, state, and local authorities are essential to respond swiftly to volcanic threats. Surveillance data informs preparedness and mitigation strategies for potential volcanic hazards. Emergency response plans, public education campaigns, and infrastructure resilience measures are all based on the insights gained from monitoring the volcano. By understanding the risks and preparing accordingly, communities can reduce the impact of volcanic events on lives and property. Researchers have uncovered a previously unidentified source of partially liquefied rock that is large enough to fill the Grand Canyon 11 times over. The researchers employed seismic tomography to provide a comprehensive depiction of the entire volcanic plumbing system in Yellowstone, spanning from the Earth's mantle to the surface. Yellowstone National Park showcases a diverse range of geothermal phenomena such as geysers, mudpots, steam vents, and hot springs. This park is situated on top of a supervolcano that has had 3 catastrophic eruptions. Prior to this discovery, scientists were previously aware of the existence of a substantial magma chamber beneath Yellowstone National Park. This chamber was responsible for supplying the volcanic eruptions that occurred approximately 2 million, 1.2 million, and 640,000 years ago. The recent research, published in the prestigious journal Science, unveiled a further, more profound reservoir that is 4.5 times greater in size. The presence of a second magma chamber does not affect the likelihood of a major volcanic eruption at Yellowstone. According to seismologist Jamie Farrell from the University of Utah, these findings have little impact on the existing volcanic danger at Yellowstone. Nevertheless, these recent discoveries do furnish us, as well as other scientists, with the necessary information to enhance our comprehension of the process by which magma migrates from the Earth's mantle to the surface. According to Professor Fan-Chi Lin, a geology and geophysics professor at the University of Utah, there is a blob-shaped magma reservoir in the lower crust of the Earth underneath Yellowstone. This reservoir is located at a depth of 12 to 28 miles, or 19 to 45 kilometers, and has a volume of 11,500 cubic miles, which is over 11 times larger than the volume of Arizona's Grand Canyon. The magma chamber is composed of predominantly solid and porous rock, interspersed with pockets of molten rock. The researchers reported that approximately 2% of it was entirely liquefied. The upper and lower magma chambers are located above a geological phenomenon known as a plume or upwelling. This plume originates from the Earth's mantle, approximately 40 miles below the surface, and transports hot materials towards the surface. Scientists have previously hypothesized the presence of a subterranean reservoir of molten rock, known as a magma chamber, but were unable to definitively verify its existence. The researchers employed seismic tomography, a method akin to a CT scan, to visualize the subsurface by utilizing seismic waves that traverse the Earth. This technique enables the differentiation of rocks with different densities. In addition, they used local and remote earthquake measurements to visualize the entirety of Yellowstone's magma system. Earthquake swarms are sequences of seismic events that occur in a localized area over a short period of time, without a single dominant main shock. Unlike typical earthquake sequences, which consist of a main shock followed by aftershocks, swarms are characterized by numerous small to moderate-sized earthquakes. These swarms can last from hours to weeks and may vary in intensity and frequency. Yellowstone National Park has a long history of seismic activity, with thousands of earthquakes occurring each year. Most of these are minor and go unnoticed by the public. However, the park has experienced several notable earthquake swarms in the past, such as the 1985 swarm near Lake Hebgen and the 2008 swarm near Yellowstone Lake. These events have provided valuable data for understanding the geological processes at play in the region. The recent swarm of earthquakes in Yellowstone has captured widespread attention due to its intensity and duration. Beginning in late 2021 and continuing into 2022, the swarm has included hundreds of small to moderate-sized earthquakes, with magnitudes ranging from 1 to 4.5. The epicenters of these quakes are concentrated in the western part of the park, near the Norris Geyser Basin and the Yellowstone Caldera. The United States Geological Survey and the Yellowstone Volcano Observatory have been closely monitoring the swarm using a network of seismometers and other geophysical instruments. These tools provide real-time data on earthquake locations, depths, and magnitudes, allowing scientists to analyze patterns and assess potential hazards. The data collected during the swarm is crucial for understanding the underlying geological processes and for forecasting future activity. Yellowstone's earthquake swarms are primarily driven by the region's tectonic and volcanic activity. The park sits atop a hotspot, where a plume of hot mantle material rises towards the surface, causing the Earth's crust to stretch and thin. This process creates faults and fractures in the crust, which can lead to earthquakes when stress is released along these faults. In addition to tectonic forces, the movement of magma and hydrothermal fluids beneath the surface can also trigger earthquakes. As magma rises and exerts pressure on surrounding rocks, it can cause fracturing and seismic activity. Similarly, the movement of hot water and steam through the park's extensive hydrothermal system can induce earthquakes by altering the pressure and stress conditions in the crust. One of the primary concerns associated with earthquake swarms in Yellowstone is the potential for volcanic eruptions. While swarms can be a precursor to volcanic activity, it is important to note that the majority of swarms do not lead to eruptions. The United States Geological Survey and the Yellowstone Volcano Observatory closely monitor changes in seismicity, ground deformation, and gas emissions to assess the likelihood of an eruption. Based on current data, there is no indication that the recent swarm is leading to an imminent volcanic event. The recent earthquake swarm underscores the importance of public safety and preparedness in regions with significant geological activity. Residents and visitors to Yellowstone should be aware of earthquake risks and follow guidelines for earthquake safety. This includes securing heavy objects, having emergency supplies on hand, and knowing how to respond during and after an earthquake. The United States Geological Survey and the Yellowstone Volcano Observatory offer valuable resources and updates to help the public stay informed and prepared. The data collected during earthquake swarms in Yellowstone contributes to the broader understanding of volcanic and seismic processes. By studying these events, scientists can gain insights into the behavior of magma, the mechanics of faulting, and the dynamics of geothermal systems. This research not only enhances our knowledge of Yellowstone, but also informs the study of other volcanic and tectonic regions around the world. The Yellowstone supervolcano is one of the most powerful and potentially destructive volcanic systems on Earth. Its past eruptions, the last of which occurred approximately 640,000 years ago, have reshaped the landscape and had far-reaching impacts. If the Yellowstone supervolcano were to erupt again, the consequences could be catastrophic, with significant damage on local, national, and global scales. The most immediate and severe damage from a Yellowstone supervolcano eruption would occur within the vicinity of the caldera. The eruption would likely begin with massive explosions that could eject thousands of cubic kilometers of volcanic material into the atmosphere. The force of these explosions could destroy everything within a 50 to 100 kilometer radius, including the park's infrastructure, wildlife, and any human presence. The pyroclastic flows, fast-moving currents of hot gas and volcanic matter, would incinerate and bury everything in their path, creating a lifeless landscape reminiscent of past eruptions. Beyond the immediate vicinity, the eruption would produce a colossal ash plume that could extend hundreds of kilometers. The ashfall would blanket large areas, potentially covering states such as Wyoming, Montana, Idaho, and beyond, with several inches of ash. This would cause severe damage to buildings, infrastructure, and agriculture. Roofs could collapse under the weight of the ash, roads and airports would become impassable, and crops could be destroyed, leading to food shortages. The ash would also pose significant health risks. Fine volcanic ash particles can cause respiratory problems, especially for those with pre-existing conditions. The air quality would deteriorate drastically, necessitating the use of masks and air filtration systems to prevent widespread respiratory illnesses. One of the most profound effects of a Yellowstone supervolcano eruption would be its impact on our planet. The eruption would inject vast amounts of sulfur dioxide and other aerosols into the stratosphere, forming sulfate aerosols that reflect sunlight and cool the Earth's surface. This phenomenon, known as a volcanic winter, could lead to a significant drop in global temperatures for several years. A prolonged volcanic winter caused by a Yellowstone eruption could lead to shortened growing seasons, reduced agricultural yields, and widespread food shortages, exacerbating the humanitarian crisis. The environmental impact would extend beyond climate effects. The ashfall and changes in temperature would disrupt ecosystems, affecting plant and animal life. Aquatic ecosystems would suffer as ash and volcanic chemicals enter water bodies, impacting water quality and aquatic species. The long-term ecological consequences could include shifts in species distributions and the loss of biodiversity. The economic damage from a Yellowstone supervolcano eruption would be staggering. The destruction of infrastructure in the immediate vicinity would require massive investment for rebuilding. Transportation networks, including roads, railways, and airports, would be heavily affected, disrupting trade and mobility. Agriculture would suffer severely from the ashfall and climate impacts. Crop failures and livestock expirations would lead to food shortages and increased prices, impacting both local economies and global food markets. The disruption of agricultural production could trigger a cascade of economic challenges, including inflation and reduced economic growth. The combined effects of infrastructure damage, food shortages, and economic disruption would likely result in a large-scale humanitarian crisis. Populations in affected areas might face displacement, requiring emergency relief and long-term recovery efforts. The strain on resources could lead to social unrest and political instability, particularly in regions heavily dependent on affected areas for food and trade. The global interconnectedness of today's world means that the repercussions of a Yellowstone eruption would not be confined to the United States. The climatic effects would affect weather patterns worldwide, influencing agricultural production and food security globally. International trade would be disrupted by transportation challenges and economic instability. The need for coordinated international response efforts would be paramount to manage the widespread impact effectively. As of right now, the potential eruption of the Yellowstone supervolcano represents one of the most significant natural threats to human civilization. The immediate devastation would include massive loss of life and destruction of infrastructure, while the environmental and climatic effects would have profound long-term consequences. The economic impact would be severe, affecting not only the United States, but the global economy as well. Preparing for such an event requires comprehensive planning and international cooperation to mitigate the risks and manage the aftermath. The immediate aftermath would be devastating, but the longer-term recovery process presents a significant challenge to humanity. In the immediate aftermath of the eruption, the primary concern would be the environmental and climatic impacts. The eruption would eject vast quantities of ash and sulfur dioxide into the atmosphere, leading to a volcanic winter characterized by significantly reduced temperatures and altered weather patterns.